Hello again. Thanks for watching this video and studying your math with Today, our topic is radical expressions. We'll talk about radical notation, simplifying radicals, doing operations with radicals, and a new operation called rationalizing denominators. As always, you should read your book. There are examples there that are different than examples I am working through, and start and stop this video to ensure that you understand what we're talking about. Previously, we used rational exponents to express roots. This is an alternative notation. It's called radical notation. The little number that's inside this little check mark is called the index. The red symbol is called the radical symbol, and what's underneath is called the radicand. Here is what we mean by a to the 1 over n. A to the 1 over n is same thing as the nth root or principal nth root of a. And we can define this further by considering that a to the m over n is the nth root of a raised to the m power, or the nth root of a to the m. We don't always write the 2 in this position. Whenever you see this symbol without anything, it's assumed to be the square root. So when you run across this symbol, that represents the positive root, also called the principal nth root. If we want the negative root, it's going to be the minus the nth root of a. This only is an issue when we are talking about even values of n, square roots, fourth roots, and so on. Here's a first classroom example. Pause the video, give these a try, and we'll see how you did. Let's see how you did. Note that here there is no real number that you can raise to the 4th power and equal minus 81, so that is not real. We will talk about complex numbers, but not in this chapter. So now the answer should be just not real. Here's some more examples. We're to write in radical form and simplify and assume all variable expressions represent positive real numbers. Pause the video and we'll see how you do. Let's see how you did. If you need help on this, ask questions in class, or go to the Learning Commons, or go to guided study groups. Here's example 3. Now we're converting from radicals to rational exponents, and again the same assumptions are in place. Let's see how you did. Here's a caveat, and so make sure you make note of that. And here's a mistake that students often make. The principal square root of a squared is not equal to a, it's equal to the absolute value of a. For example, if we were to take a to be minus 6 whole squared is going to be 36, but the principal square root of 36 is 6, so it's the absolute value. You see it makes a difference whether a is even or odd. Here's some problems. Do these and then we'll see how you did. Let's see how you did. Here's an example of what I was talking about before. I'm going to raise minus 3 to the 4th power and then take the 4th root. I get positive 3, not minus 3. Here are rules for working with radicals. You should understand that these rules are only true when we're talking about those variables representing non-negative real numbers, or they're also true for 0, except you can't have a 0 in the denominator. Make note of these. And we also define when a radical is simplified. Sometimes the direction call for simplifying radicals, and so you have to have all these conditions working. And in particular, you do not leave a radical in your denominator when you simplify. Here's an example simplifying radicals. Give these a go, and we'll see how you did. Let's see how you did. This could have also been simplified. We could have called 8 2 cubed, and this could have been the fourth root of 2 as well. There's some more simplification problems. Pause the video and see how you do. Let's see how you did. Only like radicals can be combined, and like radicals have the same radicand and the same index. You can only combine like radicals. So here's an example 7. Let's see how you do and see how you did. Ask questions as you have them. Learning Commons guided study group or in class or otherwise. Here's another example, simplifying radicals. These are the answers that you should get. We can also multiply radicals. Now notice that this top one is of the form a plus b times a minus b. So the middle terms are going to cancel out when you use the distributive property. So you multiply these radical expressions and, as always, simplify your answers completely. Let's see how you do. These are the simplified answers to that example. Often we need to rationalize denominators. You can't have a fully simplified answer with the radical in the denominator, and so we will multiply by a special form of 1 to cause that to happen without changing the value of the initial expression. So here are some problems that you want to solve. Give them a go, please. Let's see how you did. Here you multiply by root 7 over root 7. Down here what you want to have is the cube root of 3, well 9 is 3 squared, and you would like to have the cube root of 3, so that's just going to be 3. So you have to multiply top and bottom by the cube root of 3, and whenever you fully simplify that, that is your expression. Again, we're simplifying so we don't have radicals in the denominator. Let's see how you do. Check your answers. The last example is going to involve simplifying an expression where you have a radical in the denominator. Again, we're going to take advantage of the fact if we take a minus b times a plus b, we'll make that into a rational number, and these are called conjugates of each other. The a minus b and a plus b are called conjugates. So here's an example for you to do. We multiply top and bottom by the conjugate of the denominator and simplify, and at the end of the problem we get this. In closing, time is precious. Each day must count. Do the math. It will make you strong. See you in class.